Hello, thanks for joining. My name is Jeff Demuth. I'm a solutions architect with Amazon Web Services and focus on geospatial, based out of Austin, Texas. In this session, I want to show you how to build a completely serverless map website that can dynamically query data from a geospatial data lake. We will create an ArcGIS JavaScript application hosted on AWS S3, which is our simple storage service. We will use AWS Athena to query Overture data, and I'll explain what that is in a second. Lastly, we'll connect Athena to API Gateway so our serverless map can pull data into our map. What is Overture? Overture Maps gathers map data from many sources, including its members, one of which is AWS, civic organizations, and open data sources. The project's goal is to create a comprehensive data sets and other map products. So with that, let's jump into it. I did a little bit of pre-work on this one. I try to keep that to a minimal, but created a couple S3 buckets and IAM roles. You can see here two buckets, just one called Serverless. This is where we're going to store our ArcGIS JavaScript. It's going to be our hosted website. And then I created another one called Athena. This is where Athena is going to store its queries. I also created two IAM roles, which is our identity and access management. One for the Lambda function we're going to create, and another one for a glue crawler that's going to crawl the Overture dataset and create the schema that we're going to use to query. And with that, actually, we'll probably jump into the glue piece first. So in the console, we'll navigate to glue. So I like to do a lot in Cloud Shell, but this one, I haven't scripted everything out. So we'll go ahead and do this one through the console. Click on crawler, click on create crawler. We'll give it a name, my Overture crawler. Next. We'll add the path to the Overture dataset. And so that's Overture Maps, US West 2. Click Add. And I can show you where to find that as well. So if I drag this over here, this is our open data registry .aws. I've got a search bar. And if you just search open data, anywhere it'll come up, but from the main page too. So you can type in Overture, and it comes up. This is also how you would find Sentinel or Landsat or NAPE or other imagery data sets. We'll click Next. This was that IAM role I pre-created. I just called it ArcGIS Glue role. Typically just needs access to S3 and to update the Glue catalog. Another thing that I did was just create a default database. But if this wasn't here, you just click add database and give it a name. I named it default. We'll click Next. And create crawler. So these glue crawlers are really nice because you can point them at any S3 bucket, CSV, geojson, Parquet. We're using GeoParquet in this example, and just say crawl through all the documents in this bucket and create a schema based on, essentially what you find. So if you've got a bunch of numbers in a column, it'll say this is an integer. But if you've got a bunch of numbers in a column and one of the objects as a string, it's going to say that that column's a string, and you'll have to clean that data. And this will take 30 seconds to run. And here we go. We can see it took 56 seconds to run. It created one table. So now we can go over to Athena. And see our default database. It named our table type underscore place just because that's the name of the folder. We could rename that, but we'll just use it as is for now. In Athena, I have to create that default workspace, so that was a bucket that I created just to store Athena query results. We'll select the bucket and save. And now we can start running queries against that table. We gotta rename this. And our query's running. Move this up a little bit. So we can see we've got a couple points just around Austin. I put in, an ST within with a buffer just of a radius around a point that's somewhere in downtown Austin. If we want, we can put a star on here and just see some of the other columns that get pulled in. So you get ID, the geometry, a bounding box, some tags, the source of the data, some categories, and some other metadata, websites, phone, social, address. Another thing too, just to show you how to browse that bucket, we've got a command line, just AWS S3 ls, like in Linux, and you put in the path to that bucket. There's some nice data sets in here. So we've also got admin boundaries, buildings with building height. Places is what we're working with now. Also transportation, so different types of road, sidewalk networks. There's a lot of good data sets in here. Yeah. So the next thing we're going to do is create a Lambda function. I'll leave this window open for now. We'll click on Lambda. And we'll call this Python Athena Overture. So I originally compiled my library at an older version. I need to update it. It's pretty easy to download. I've got Shapely, which is a Python library, and that requires NumPy and maybe a geojson library. I'll pull it up in a second. But basically I've spin up an EC2 instance with Amazon Linux and pip install those libraries and then zip it up and upload it, and that's how I'd upgrade the version. The one I've got now is just using, was compiled with 3.8 when I built this a while ago. And if you haven't used Lambda before, it's super convenient. You just get a text box here where you can start typing in your Python code. I'm going to upload a zip package that's got those Shapely libraries and that in it. And then we're just going to upgrade or update some of the configurations here. So 3 seconds. Because we're querying data in S3, like your responses aren't going to come back in milliseconds or single digit seconds. I mean, they can come back in single digit seconds if it's a small query, but this is a pretty big data set. I think the whole Overture data set, last I checked, was about 90 gigs. So to query that much data, you're not going to get a response reading from S3 back in milliseconds. Typically, these queries come back in 30 seconds to a minute, and that could be improved with geohashing, which I'll give a demo of that later. I've got this data set already geohashed in another bucket. I'm also going to update it to my pre-created Lambda role. This Lambda role just has the ability to invoke Athena. Just to show you what this function looks like. I just copied my query here. So we've got Shapely, geojson, our Boto 3. We're going to create an Athena client. We're going to run that same SQL query against Athena. We'll get the results. Athena is going to be an asynchronous query, so you run the query. Then we'll just wait for a second, and then we'll pick up the results from it. I've got a loop I'll have to update this with that'll kind of poll for it to be completed and then go grab the results. That's a much better way to do it. And then we use Shapely to essentially convert the geometry, which is in WKT, which is a text format, or actually technically it's WKB and Overture. And then we convert it to WKT and then convert it to geojson, and grab some of the properties and add those as properties in the geojson, and then we're going to return that to API gateway. So let me go ahead and upload this function. And you'll just click upload from, click the zip file. I'll make all these files available as well so you can download them. That's a pretty big function, about 23 megs. I'll save that. I'll upload. Now, because this is a larger function, we lose the ability to edit the Python in it when it's that big. So typically what you want to do is export those as layers, Shapely and NumPy, and then it retains the ability to have your text window here and update the Python, which is super convenient. And we'll go and we'll click test. So it's just running that SQL query against Athena. Now normally this would run quicker. It actually probably completes in a couple seconds, but because I've just got a 13-second sleep function in there so I know it'll take about that long for the query to run and finish, and then I can grab the results, and then I package that up as geojson now. Put it in a body function because we're going to return this to API gateway next so that we can pull it into our ArcGIS JavaScript website. And that looks good. So now let's go to API gateway. And we'll create a REST endpoint. We'll say it's a new API. We'll call it ArcGIS. Create a method. We'll just do a simple get. We'll enable proxy integration. And here's that Python function we just created. Create method. Deploy. We'll have to create a stage. Normally you'd have development and production. So now we've got our URL. If we paste that URL into the browser, same thing as we were seeing Lambda, returns a 200 HTTP code with the body of the geojson. So now we get to the fun part. Let's create our serverless website. So we'll go into our bucket we created. And here I'm going to upload a very simple JavaScript website. And I'll show you what that looks like. So super, super simple. Pull in the ArcGIS JavaScript library. Create a map. We're going to create a geojson layer. We're going to put in that URL. And actually, before we use that URL, I'll show you something else that's pretty neat. Create the map, create the view. I'm going to have it center in on around Austin, although it's going to be a kind of a high zoom level. And then the div that's going to hold our map in HTML. Let me upload a geojson file though. So we can dynamically generate that geojson, but if we already have the geojson generated, like this is an outline of just country boundaries at pretty low resolution, we can also pull that into the map, and that's super fast because everything's pre-generated. That is essentially millisecond response. Now this isn't a public bucket, so I'm going to just create a pre-signed URL for this object. And let's put that in here. So that's a pretty long URL because since it's a pre-signed URL, it's got the authentication to access the object. And we'll go ahead and upload this as well. So I'll upload the index.html file. Successful. And again, if this was a public bucket, you could just hit the URL, but I don't have this as a public bucket. Or alternatively, you could put CloudFront in front of it. But this is kind of nice too, because you get a fully functional website and it's authenticated. So only users who have this URL can actually hit the website. And here's our website coming up. Here's that geojson layer loading. Again, it's just the boundaries of the countries. So now let's go back and update that back to our original Lambda function URL. upload. And this is essentially how you do like versioning with a serverless S3 website. Is you could upload two different versions of this index.html file and have kind of DNS swap between them. Or you could have, you know, a dev bucket and a production bucket and have index.html files that live there. Now it shouldn't load that geojson layer. So now it's going to take that 13 seconds that I have in there, and then we'll see a couple points up here around Texas. And there we go. So we can zoom in. And we've got a couple points around the Austin area here. These were just random places. And that can be completely dynamic, so I'll show you an example where I've got like a text box on my map and I could pass in, you know, either SQL queries, or if I've got pre-generated SQL queries that I can pass through API gateway to that Lambda function to change the results, to get different types of data. Let me pull up a couple of those. So also with that geojson, you can write some JavaScript to pull down that geojson file and make some changes to it and then re-upload it. So here's kind of that Overture Explorer that I built, so I can say show me places. And this one I have a little pop-up. If you click on it, it shows those tag values. These are some of the other data sets in there, so I can also pull buildings. We can pull some roads. And what I do here is I pass in the extent that's visible on my screen as part of that dynamic query through API gateway to Lambda. And so it's only going to show me results for what I'm viewing on the screen. So here's a paved footway. And then I've got a little architecture diagram. So this is what that looks like. Our S3 static website, API gateway, Lambda, Athena, S3, compressed Parquet, returns as geojson. You can do some pretty neat, all kinds of neat things with this, so possibilities are endless. So a couple other quick call-outs. This is querying the Athena dataset, Overture dataset with Athena, but you can also do joins with that. So if you've got some of your own data in S3, you could run that glue crawler on it, and you could actually do geospatial joins with Athena across the Overture dataset and your dataset. Also want to call out really the cost of the solution being serverless. If you're not getting much traffic, you know, maybe a couple thousand requests, I mean, the bill for this is probably going to be under $1 a month. If you're seeing, even if you're seeing super high traffic, you know, 10,000, a million queries, you're probably still under $10 a month to host this. Because it's serverless, there's no maintenance, or I'm not needing to upgrade or patch the Athena database. Everything is upgraded and maintained by AWS. I don't have to patch web servers. This is just an index.html file sitting on S3. That's really the power and the big benefit of of doing things serverless is there's no maintenance, there's nothing to manage, and then you're paying per request, per event, and if it's architected correctly, that's going to be pennies. One way to make it a bit more efficient, I talked about, I think I've got it on my diagram here. No, not on this one, but essentially geohashing that Overture data set. So in one of my accounts, I downloaded the Overture data set, calculated geohashes off of all the objects, and then when I run my query, for example, when I do this query that just gets the extent, it just shows me what's in the screen. It's actually reading, in the first version, it's reading that entire Overture data set, which, you know, it's not very efficient. It might read several gigs. I have a limit on there, so it could potentially read several gigs before returning a result. Where if you partition that data set by geohash, you're probably going to reduce that from, you know, a couple gigs read each query down to potentially a couple megabytes read each query. That's going to go a long way as far as scaling this to, it's going to be much quicker on the response time because the queries are going to come back probably in single-digit seconds. And then from a cost standpoint, you're only getting charged because you only read a couple megs versus being charged for reading a couple gigs. Alright, well that's all I had for this video. If you liked it, go ahead and subscribe and, you know, give me a like on the video. Feel free to comment if you'd like to see any other content. Thanks.